Have you ever wondered what it takes to produce asphalt? Or what it takes to run the greenest asphalt plant in Canada? Well, if so, we hereby invite you to join us on one of our all roads construction asphalt plant tours that happens on our site at 2320 Rogers Avenue in Coquitlam. How can we make 32 different mixes from one plant? And how do we know if we have quality asphalt being produced here? And what does it look like down on the road? All of these questions can be answered if you take a tour of our asphalt plant. More than just being businessmen and contractors, we truly want to educate the public. We want you to realize what good products look like, and how you get good products using the best control technologies available, utilizing the greenest asphalt plant in Canada. The perception is asphalt plants are dirty and bad for the environment. No longer true, and we'll prove that to you today by going through multiple components. This plant is the greenest not because of one component, not because of two, not because of three. It's actually a dozen components all added into one plant that there's not another plant in Canada that has all of them combined, including some green space. The first step is when a truck comes into all roads is a release agent. It's an environmentally friendly release agent that gets mixed with water and it goes over to the spray bar. You follow, there's a little gray spray bar. What happens there is a truck drives underneath there and it automatically knows where the truck is because of an electronic eye sensor, and it sprays the release agent into the back box of the truck. You might say, why have a release agent in the back box? If you don't, the asphalt will stick to the actual metal and it kind of gums up the truck. So many years gone by, what we always used to use, the best release agent out there is diesel. So you used to get guys that would come out, they'd have these little cans, they'd pump their diesel cans, they'd climb up on their back tire and they'd spray diesel in the back of your truck. Diesel is not environmentally friendly. No longer welcome on a site like this when we have this much access to the river, okay? So we use an environmentally friendly release agent and we dose it for the truck driver so we know what's going in the truck. So we do that kind of free of charge just to make sure everything stays environmentally friendly. So they get sprayed, they go around the circle this way, they go on the scale where you see these big gray tubes. These big gray tubes that you can count 5 of are called silos. But each silo holds 200 tons. So total in the silos we can hold 1,000 tons of asphalt without making anything. It can all be pre-made. So the truck driver comes around and then via radio, because we don't want him to get out, via radio they tell him exactly where the silo needs to go. By the time they get loaded, what the other component of this environmentally friendly, greenest kind of asphalt plant is, we're trying to minimize our carbon footprint. Now when you think about that, that means all of the trucks on the road, what are they doing? Outside of our plant, what are they doing? What would happen is the scales were not long enough. So we would have to load either the truck or the transfer. We'd go forward, backwards. They'd put another ton on me, move forward. Oh, I'm overweight. Now pull over, get the loader, take it off. And you'd waste all this time while the trucks are idling. So we made sure that we had a scale that was fit properly. So when they load the truck and the transfer, they can tell exactly to the ton, to the specific weight of the truck, that they're going fully loaded, but not overloaded. That's the key. We don't want to send them out illegally, but we want to make sure every last ton gets on that truck. Because if we produce 4,000 tons of asphalt through this plant today, and you left 1 ton off of every truck that goes out, in the end you might have to put on 3 or 4 truck and transfers all day long just to make up for the fact that you're sending them light. So these are things some people don't think about, but our carbon footprint and the trucks on the road make a difference. The other thing is a lot of our aggregates, half of our aggregates come in on barge. And why do they come in on barge? Because if they come in on truck, that's more truck traffic out on the roads, the city streets, and so forth. That's why we're facilitated here. But everybody is located in our electronic system, if you will, by their license plate. So the minute we punch in the license plate, we know exactly what that truck's legal tear is, so we know how much weight to put on them. These two tanks behind me, and there's a third one that we just added, that is where we have our liquid asphalt. So that is what in our world we call our binder. It's what you people typically would call tar or oil. That's what gets mixed with the aggregate itself to be able to make asphalt. People say, how do you fill those tanks? Well, what happens is a tank truck comes around, he drives around the circuit, and he lines up right here. And this tube that you see running along the bottom of the concrete foundation, he hooks up to his tank truck and then sucks basically the oil from the tank truck into our tanks there. What happens as time has gone on over different asphalt plants is we never really thought about the importance of having the right kind of slope on a truck. So from a gravity perspective, all the liquid asphalt gets out of that tanker truck. So you might not even recognize it, but there's a slope to this. So when the front wheels are out here, there's a very gentle slope that kind of goes back on an angle like this. All these things we engineered because when I took possession of this property, it was absolutely vacant and bare. So for the first time in my 40-year history, we were able to think of every component and figure out what's the best way to build the plant with all these problems we had over the years. This tank farm that you see, same thing. It is all engineered so it's earthquake proof. It's also volumetrically designed, so if in an earthquake those tanks fail and they all kind of crumble, it will hold all the volume that goes in there. So nothing can leak out into the river. Up at the very top of these tanks, you'll see that there is a little black, almost looks like a little stack on top of the tanks here. Those are condensers. But what will happen with the liquid asphalt when it's hot and when you're stirring it, it will create blue smoke. And what those condensers do on the top, when you look at it, there's nothing, you can't see anything coming out of it, right? It basically takes the blue smoke and it liquefies it and puts it back down into the tank. So in a sense, it's self-recycling itself. This is modern technology that other contractors don't have yet, but it was one of the components that Metrovan wanted to test. Was there were 17 locations around here on the site that they wanted to test to meet their air bylaw permits, and that was one of them. So we solved it by making sure that we put condensers on it. Now, just before we move around, you're going to see that there's all these aggregates around us. A couple here. When we get to the other side, you'll see some. People ask me all the time, why is like this one covered and that one not covered? The reason being, in making asphalt, what you're doing is you're drying the aggregate before you make it. So you can imagine around here, not right now, but it rains a fair amount. If we have it constantly raining on a fine product like sand, it holds the moisture. Now we take the moisture and then we have to dry it. Typically what that means is you're going to add more emissions into the air. Now they say, Rod, why is this one not covered? But you'll notice it's clear aggregate. There's no fines in it. So the rain will hit it and it washes right down through the bottom and out. So that's the difference. But from another environmental perspective, we have these covered so that we don't have to overheat the aggregates to dry them out just because we didn't cover them. So once you get here, I'm going to get your eyes drawn to what is black on the plant right there. That in itself is a glorified tiger torch. So in our asphalt world, you know, it's our burner. And it's lit with natural gas. Why natural gas? It's the cleanest burning fuel. And through that burner, which is a ultra low NOx burner, you want to have a super high caliber torch so that it limits your emissions. That is one of them without going into details. That's there. Now, let's go up top where the silos are. There, you'll see there's a little slat that goes up on an angle. That's where the asphalt is made, and it goes up the conveyor, and then you pick which silo you want it to go in. Once the asphalt goes into that elevator and it's moving up to the top and then getting dumped into the silo, it creates blue smoke. All of that is an emission that goes into the air. So Metrovan said, we want you to limit the amount of blue smoke that goes into the air. No problem. Money can buy that. It's reality. It's not like we're extra special. We just afforded to pay for it because it was important to us from an environmental perspective. Everything in that slat is covered. Some plants you'll see it's not covered. Everything along the top of all the silos is sealed off. So in full production, you'll see zero blow smoke going up into the atmosphere from this plant. Another component that makes it one of the greenest. The next thing is I'm going to go over here to this big square box that you see. It's got a little chamfer down at the bottom. That is called a bag house in the asphalt plant world. For you today, I just want you to think about it as a glorified vacuum cleaner. So when we're in production and we're heating up aggregates, it creates a bit of dust. What it does as a vacuum cleaner is it takes suction and sucks all the dust that we're creating in the heating process and sucks it back inside this bag house or vacuum cleaner. Inside there's 870 bags, like this big, canvas bags, and all the dust is getting collected on the bags. And then every once in a while it reverse flows, blows air out at it, goes psh. What's going to happen with the dust? It's going to drop, right? That's why it's chamfered down at the bottom, and if you follow it, you'll see down below there's a little conveyor that goes back up. So all the dust that we create in the process of making asphalt gets returned back into our asphalt mix without it going up into the air. Okay? There's another component. The next is, can you see the stack going up almost like a tailpipe of the plant there? Follow your eye down from that stack and you'll see right down at the bottom there's another little tube that comes up. It's a little smaller. Follow my arm here. It takes this bend and it goes over and it goes under the condenser and back to the big flame. You see that one? It's another add-on component for an asphalt plant. It's called a flue gas recirculator and demister. Not going to bore you with the details. In the final product, after everything is made, what goes up out of that stack, it grabs what's there, any of the flue gases left, and by suction it sucks it back and back into the burner over there and reignites it. So let's put this in perspective, just for repetition, for emphasis. No blue smoke going up into the plant, no blue smoke coming out of the silos. Any of the blue smoke comes down and it gets reignited in the burner. So all the blue smoke's getting reignited and burnt by itself. Over on this side, all of the dust is being collected and being recycled back into the asphalt. Just before we go up the stack, all of the flue gas goes along and gets recycled and gets reignited through the burner. This is modern technology. This is something that we pay for. We didn't design it, we pay for it. But it's in our backyard and it's one of the components, when you add them all together, which makes it the greenest at the end of the day. Now, we're going to talk just briefly about the 32 different types of asphalt we currently make here. Here's an engineering goal that we have. We only have so much room. So between about 6, maybe 8 different aggregates, including some recycled asphalt products, we need to make 32 different types of asphalt. How do you reason on this? Well, imagine if you're baking cookies and your grandma gave you a recipe that's different than your mother-in-law and different than this person and that. They say a little bit of this, a little bit of that, put a pinch of this in, put so much flour in. Oh, if you want some good cookies, put some almonds in, do this, do that, right? It's a recipe. When it comes to asphalt mix designs, don't get carried away. Oh, mix designs, I'm scared. What is a mix design? I don't know how to read it. A mix design is basically a recipe of what's gone into the asphalt. And I guarantee it is made up of about maybe 3 or 4 components. Primarily 2, aggregate, different size rock, and different types of liquid asphalt in those silver tanks. We were the very first here to be able to have an automatic dosing fiber machine. So people say, well, why would we put fiber in asphalt? When you think about the pyramids in Egypt from being built thousands of years ago, anybody know what they used to put in their bricks to make them strong? Horsehair. Okay? So people say, oh, put fiber in the mix, it's such great technology. The Egyptians did it thousands of years ago. They put horsehair inside of the bricks. What do you think to be the benefit of putting something like this inside of asphalt or even a clay brick or something? Exactly. It adds to the tensile strength of what's out there. It locks things together in the aggregate. So the Ministry of Transportation has spec jobs where they use fiber in their mix, because when you drive the highway, it's broken and cracked. And they don't want to redo the subbase. So what they do is they say, all roads, come out, put fiber in the mix. We know it costs a little premium, but it's going to give us some more tensile strength on those broken, failed areas. If you drive out on Highway 1 right now, you'll see we're doing some deep repairs prior to us overlaying it, and it has fiber in it for that very reason. So if you notice in here, everything is paved. That's not necessarily typical of all asphalt plants. Anything that is that vibrates or moves a little bit is all kind of welded down onto concrete slabs. The whole idea is this is not going to vibrate itself to death, which is one of the nightmares we used to have. If you look behind you, you'll see there's drains all over the place. The idea is any dust that potentially is going to fall to the ground, because we have misters, I mean, too bad we're not running here right now, but wherever there's a belt that's moving and aggregate falls, it creates more dust. So Metrovan said, we want you to have a misting system just to knock the dust down. And then once you knock the dust down, where's it going to go? Well, it all lands on pavement and it all flushes back through to like what you see here. We have a whole storm drainage system, StormTech, state-of-the-art drainage system. It's huge. It's out underneath the asphalt. It collects up all of this rainwater and dust particles and so forth. And it's a great big huge monster silt separator, an oil separator and everything else. And then the discharge actually goes out into the river, which we get monitored all the time. But just to give you peace of mind, obviously if it's getting checked all the time, you know everything that's going down has been cleaned already. So remember I told you earlier that Metrovan can come down at any point in time and see what's going on? This is something that no other plant has. It's a particulate monitor. Won't bore you with the details. What it's monitoring is what's going up past the flue gas up the stack. It's monitoring how much particulate is actually going to go up into the air. Now you'd say, why is that important that it monitors that? It's because in the production of asphalt and this great big huge vacuum cleaner, have you ever had it before when you're trying to vacuum and it's not sucking very well because it's full? Something's wrong, it's plugged, right? Well, that's a big vacuum cleaner. Sometimes something goes wrong with one of the bags, but you'd never know it if you actually didn't go in and look and inspect the bags. And when would we do that? Well, once a year before we get our stack test done, because we want to make sure everything is great. But now what happens is all of a sudden that monitor will flicker and say all of a sudden a bunch of particulates going up into the sky. Why? Right? So it's a due diligence component again, so that somebody like Dennis as the plant manager can come by and say, something's wrong in the bag house, get in there and fix it. So we recognize it right away so that it can be fixed right away so that we're not that kind of polluting plant, as people would say, with extra particulate going up into the air. RAP, recycled asphalt products. That's basically is asphalt like this that you're standing on that comes into us all broken up, that's been excavated, and our great big grinding machines grind it up. We bring it over, we stockpile it over there where you see that truck going up on the hill right there, and then we bring a portable crusher in every couple weeks and we crush it up, and we can crush it up into different sizes. So what's really frustrating me in the industry is the ministry lately has been saying we want less RAP because we think our roads are rutting. And it's not actually that the asphalt is bad, and it's not that the RAP is bad, it's that some of their criteria that they specify is bad because they're using technology from 40 years ago. All right? We're trying to bring them up to speed. What is bad is allowing asphalt like this on the ground that is perfectly good to be reused to not be reused, because we're going to deplete all of our aggregate sources. So if you don't use it, one, you're crushing another product from a quarry somewhere, and one day we're going to run out of the quarry material here, and that's going to be a big problem and a big cost. Secondly, we're bringing more tanker trucks in because we're using more liquid asphalt instead of getting it off of the rocks that are already there. So the whole environmental talk that everybody gives, I want to be sustainable, you blow it all out the door when you say no RAP. And most municipalities are in that situation where they'll just a small percentage. And it's just an educational thing. So if you can take nothing away from today, if you want to have a discussion about RAP down the road, by all means, let's do that city by city, whatever your case may be. But at the end of the day, RAP is a very functional, stable product that can be added to asphalt that is environmentally friendly. Do not be afraid of it. Don't say no to it. That's old school. It's technology, takes it and deals with it properly now. You don't smell asphalt. Do you smell asphalt right now? Okay? So take everything I said and all the technical stuff out of it. If you walked up to a site in a dump truck right now, you'd smell asphalt immediately. We're at the production facility and you don't smell it. That shows you how green it is, how everything is contained, how it's all been put together here properly. And a lot of it has to do with the electrical stuff and components. So again, it's all of these things intertwined together that make the difference. Now let's talk about where we make asphalt. So this is what we call the drum. This is where the asphalt is actually kind of all put together and made. On the far side over there, we talked about the cold feed, the aggregate coming in. Cold meaning it's aggregate, but it's not hot yet. It gets dropped into this. As we're running, this thing is spinning like this. Remember we got the big glorified tiger torch, the black thing down at the end. It blows a flame all the way up to right about where I'm standing here. So there's a huge tiger torch flame all the way up the side. So as the aggregate comes in, there's a bunch of flighting systems that takes the gravel and fans it out. It's fanning out the gravel. The Tiger torch is there. It's heating up the aggregate as it goes this direction like this. Heating up the aggregate, heating up the aggregate, heating it up, right? At the last minute, we put the wrap into the mix. The reason being, we are trying to control moisture before the wrap. I won't bore you, but it's a moisture control issue. So the wrap gets added in at the last minute to the hot aggregate, and because the aggregate's already hot, it kind of gloms onto the asphalt that already has liquid around it, and it already starting to bind itself together and heat itself all at the same time, without gumming up the front of the drum by putting the wrap in too soon. So the wrap comes in on what we call here this wrap collar. It comes in at the last minute. On the other side of the plant, you already saw we're adding fiber, if that's the case. It's going in at the same time. Now, the liquid asphalt that comes from those big tanks gets sprayed in basically within this component here, right here. So now it takes all of the products and it basically sprays the liquid asphalt in, and it's doing its final mixing. When it's all done and it's finally mixed, up the slat it goes, and then into the silo. So we took our aggregates that we learned about, we took our liquid asphalt that we learned about, and we just put them all together here in the big mixing chamber, just to simplify it. And that's how asphalt is made. Now I just want you to think about it one more time. You smell asphalt? You're standing all around it. It's like the drum, it's here, those are the tanks, right? That is the proof of everything that I'm saying. We have our own, and we have our whole entire CCIL certified lab for one reason only, our own quality control. So we're not trying to give you our testing. We're testing everything before the engineers test it to be able to minimize any problems before it's too late. So we have our own team that does it. If you're ever out on a job, you'll see why is Contour out there and then All Roads is doing the same damn thing. It's because we want to control what's being said out there and what's being done, rolling patterns and everything else. I want us to know what we're putting down so when they come out on the job site, we can communicate on their level, right? We're the ones putting it down. We should know what we're making, not having them tell us what we're making. So that's been the goal. And you wonder, what do they do all day? They take samples of the aggregate constantly, and they're constantly sieving it. So they're drying it, and they're figuring out moisture contents. We have an AC burner over here. We have a shaker over here. So the AC burner, what is that for? We take our wrap that's coming in, which is constantly changing, and we're doing extractions off of it to see how much liquid asphalt comes off of the rock so that we can actually fine-tune our mix designs and know how much virgin liquid asphalt we need to add based on a daily consumption. So not a monthly, here's a big stockpile. It happens daily. 24/7, we've got the monitoring going on. The main idea is why? We don't want any asphalt leaving the site that's not going to meet spec. We'll know it before it leaves the room. We know that 98% of the time, it's going to be accurate. But especially when it comes to inspection and testing, it is not an exact science. So we typically will run this plant 24/7. So the idea of this plant was have one central plant, state-of-the-art plant, and run it kind of constantly. And so we have different crews that come in at different times to be able to run the plant. If you look this way, it was all designed so that you could see some of the most important components. Look where that drum is. Remember we talked about the aggregates dropping in on one end? You can see that belt there. You see where the wrap goes in? You can see where the wrap goes in. You can kind of see all the important components. You see there's a liquid asphalt tank truck that just came in. That's how the liquid asphalt comes in, and he's offloading right now. When you think about a plant and a safety perspective, when he's unloading hot asphalt, that's a safety component that you want to make sure you've got covered off. So you want the plant operator to be able to have a visual on, is he unloading it properly, what's going on there. We made sure that we could get on camera, and he can flip through different toggles to be able to see everything on camera. You can see a license plate number, so he can put it in the scale system, so he knows exactly what that truck terror is going to be. Right? Everything is all computerized. Now the computer thinks it all through. We put the 32 different mix designs in. It knows all the proportions. It controls all of that. Doesn't mean that the operator doesn't have to know what's going on, but that's how technology has changed over the years. So this is a community service that we offer, and we're proud of it, and it's fun. If you're an engineering department, if you're an authority, if you're a municipality, we welcome you to our site. Bring a team. Let's make it fun, let's make it educational, and let's prove to everybody that asphalt plants are a sustainable future for the road building industry.
haven't seen before any plant in person. That's my first plant visit. It was a great experience. Rod did a great presentation of how the plant is running and how it is reducing the impact on the environment. Other plants should sort of replicate with that.
Yeah, super impressed. I've worked a lot with asphalt through my experience in operations as well as inspections, and to be on a facility with this size and not even smell any aspects or any scent of asphalt is incredibly impressive, and it just shows the professionalism that's utilized at this facility.
Because your footprint is so tiny, and how Rod talks about how he had to really think about where he placed his Lego pieces prior to building it, and how he has to meet the standard emission that Metro Vancouver set out, which is higher than most. I think that's where other plants learn, maybe come and take a tour and understand how Rod and his team has produced such a green asphalt plant. And like he said throughout the tour, can you smell the blacktop? And you really can't.